Over the course of this semester, my group and I conducted a long-term experiment. Throughout this video, we will explain the results we discovered and share them with you what the results mean in context. Our lab experiment was testing if male or female Madagascar hissing cockroaches are faster. Madagascar hissing cockroaches are found on the African island of Madagascar. The adults get up to the size of 3 inches, females typically being a little larger than males. The adapted biological function of the female Madagascar hissing cockroaches could make it more likely to escape predators. Unlike most cockroaches, Madagascar hissing cockroaches are wingless, which enables them to run quicker. So what we concluded from what we have researched, we hypothesized that females would be faster due to relying on their speed to protect their young and escape from predators. We have conducted 4 different trials using 2 different females and 2 different males each time to test the speed it takes them to finish the maze. The materials we used was a maze, a randomly selected equal amount of females and male Madagascar hissing cockroaches, and a timer that we used on our phone. Our experimental variables were the female and male Madagascar hissing cockroaches, and our controlled variables were the size of the maze, the environment they were in, and the same time allotted. The way we conducted this experiment was by placing the male or the female Madagascar hissing cockroach at the very beginning of the maze and starting the timer right when we set them down, and stopping the timer as soon as they finished the maze.
When looking at the bar graph we have presented to go along with our experiment, you see that the female MHCs finished somewhere around 12.5 seconds, and the male MHCs finished the track somewhere around 59.5 seconds. The reason for this huge difference is because our males never actually finished the course. They did take some steps into the course at some point, so we did measure how far they got, and then we measured it out to the end of the course and multiplied respectively if it was by 4 or by 2, depending on how far they got into the maze. We decided in our experimental design that we would give each cockroach the time constraint of 60 seconds to complete the maze. So if they did not complete the maze within 60 seconds or they had not moved within 60 seconds, they were given a default time of 60 seconds. That's why you see the males being so high in this instance. Throughout our experimental design, we did our best to try and make everything as accurate as possible to measure out how far they got, if they got into the maze at all, and to measure how long it took them to get there as well. We tried to make sure that our data was just as clear as possible, with it being within constraints of them not moving. By just looking at our data chart, it would be easy to assume that, yes, female Madagascar hissing cockroaches are faster than male Madagascar cockroaches. However, that's not something that you can really decide when your males are not moving into the course at all. And it would also be easy for us to say that female Madagascar hissing cockroaches are just more active than male Madagascar hissing cockroaches. But whenever we actually performed our t-test, it shows some things that make our results not valid. Once we performed our t-test, we could see that there were some major problems within our experimental design and within our experiment itself. So I'm going to go over that a little bit with y'all. Our t-test was a one-tailed t-test because we were only trying to see if females are faster than males. That's all we were doing. We didn't have any food at the end. We didn't do anything like that. And so it's a one-tailed t-test. Our degrees of freedom were at 16 degrees because in each group we tested 9 Madagascar hissing cockroaches, 9 females, 9 males. So 9 minus 1 is obviously 8. So you do that for both sides. And then 8 plus 8 is 16. So our degrees of freedom were 16. If you look at the t-table value at 16 degrees of freedom and a significance of 0.05, it should be 1.746. And then whenever we did our t-test, our real t-test, our value came out to 14.36815, and the p-value is 0.1. So when a p-value is greater than 0.05, we know that those results are not significant. And so we did know that by performing the t-test, our results for this trial were not significant.
Unfortunately, our experiment did not provide any conclusive results, and this is for a number of reasons. Reason one being that we had too few trials. The uncertainty and craziness that we have faced this year limited the amount of time that we could have spent in the lab, which directly affected how many trials we could have ran. The second reason being that we had a small sample size. The third reason is that we had inadequate motivation of the Madagascar hissing cockroaches to complete the maze. We had a common trend of placing a roach in the maze and them either not moving at all or taking a couple steps and then stopping. And this was more common in the males. Now, it is possible that females are indeed faster than males. However, our experiment cannot support this hypothesis. So what are the implications of this study? Well, we can imply that no other study, or at least any that we could find, has been able to provide a conclusive experiment about the differences in speed between the male and female MHCs. It also leads us to imply that there are indeed biological differences between the males and females that could affect if one is faster than the other. This study also leads us to ask ourselves, why didn't any of the male MHCs finish the maze in which they were put in? Cited above are the works we referred to for our background information or anything we needed throughout our experiment. On behalf of Caroline, Natalie, and myself, we'd like to thank you for your time and all the hard work you put in through this semester. And we'd like to wish you a happy holiday.